today what we're going to focus on is the algebraic component of solving inequalities. There's a very important concept that we have to get to when we get to solving logs, and that's determining when the restriction occurs. So pay very close attention to that portion once we get to it in our notes. Okay, so in order to solve this problem properly, we've got to really focus on getting those exponents out of the exponent, and the way we're going those values out of the exponent. And the way we're going to do that is by using properties of logarithms. So I'm going to begin by adding a log to both sides. Now I agree that I can change these bases to be the same number, but since that's not going to occur on every problem, I want to go ahead and not focus on that for this problem because we do have limited examples that we're going to cover over this topic. So if the bases stay the same, then you can use properties of exponents to solve this problem. But if there is no possible way to get the bases to be the same, then we've got to use properties of logarithms instead. So now by doing this, I can remove both of your exponents by using the power property of logarithms. Next thing I'm going to do is I'm going to move my logs to the same side. And then I'm going to move this or rewrite this so it shows more appropriately what's going on. Alright, this value of this log turns out to be 2. If you need to see it, this is the change of base formula, so let's move it back to what it was prior to being in the change of base. 2 to what power equals 4? When you evaluate that log, you get 2. So now I'm going to rewrite that as x minus 1 times 2. Distribute that through 2x minus 2. Solve for x by subtracting the 2x to the other side, and then I have negative x greater than negative 2, so x is less than 2. Okay, now as before, remember, divide by negative, switch the symbol. As before with inequalities, what we need to do is we need to utilize that number line to determine if our solution is in fact accurate. Because remember, sometimes the inequality does accurately depict what's going on, and sometimes it doesn't. So we have to be very careful about that by choosing test points and plugging them in. I'll go ahead and choose 3 on this side and 0 on that side. Once you plug 0 into this equation and inequality and 3 into that inequality, you will get a true result here and a false result here. And our answer is that. If we write it in interval notation, we'll use parentheses. Now the reason why we don't have to worry about the restriction on this is that the x value is not restricted by an asymptote in the exponential function. It is, however, in the logarithmic, so we'll get to that in a few minutes. Okay, again, I'm going to utilize the properties of logs here. By adding a log to both sides, I do not change the inequality at all. And what that does allow me to do is use the power property of logs to remove the exponent and place it as a whole number. Divide out this log to the other side. And then I will go ahead and evaluate that logarithm right there. What I get from that is x greater than or equal to negative 3/2 times x minus 1. I'm going to distribute that through, and I get x is greater than or equal to negative 3/2 x plus 3/2. I'm going to add that 3/2 to the other side of the equation. And I get 5/2 x is greater than or equal to 3/2. Multiplied by the reciprocal, that's 2/5. 2/5. And x is greater than or equal to 3/5. Okay, again, we need to ensure that what we're looking at is accurate here. So what we're going to do is draw our number line, make sure that what we are actually doing is correct. We'll put our intersection point of 3/5 in the calculator, and we'll choose test points of 0 and 1. When plugging these into the equation, you want to test for their validity with the true or false statement. You'll notice here that your true statement is here and your false statement is here. So that does contradict what has been stated in solving this algebraically. That is why it is so important that you do your test points in order to determine what's going on. So that means your solution is negative infinity to 3/5. All right, our last two examples for today are going to focus on logarithms. The first thing I want to point your attention to is the restriction. Okay? In question number 3, the restriction occurs at this logarithm right here. However, in question number 4, we have to make a choice. Where does the restriction first occur? Because there is a restriction on this logarithm, and likewise, there is a restriction on this logarithm as well. Okay? The argument of the logarithm in 3 and the first logarithm of 4 is x. That means that I'm going to set the argument equal to 0. That is where this logarithm becomes undefined. This one's a little bit different because the argument is x plus 9. X plus 9 equals 0. Therefore, this logarithm becomes undefined at negative 9. Very important to understand where your arguments become negative or become less than 0, because that is where they become undefined, and that is the restriction on the solution. So now let's go back here, use properties of logarithms to condense this to log of x divided by 2, and that's log of 75. Now remember, our properties of logs state that if there's a log on both sides, we can cancel that out as long as the base of those logs are the same. So we'll cancel those out and we get that. Multiply both sides by 2. X is less than or equal to 150 is what you're looking at. However, we cannot look at this without first test points. So we're going to do 150 here, and then what I'm going to do is I'm going to place this restriction on the number line as well. Anything beyond this restriction is undefined, so I'm just going to identify that as undefined down here. You don't have to do that, but I want you to understand that that's what's actually occurring from this direction on. Okay? Now what I'm going to do is I'm going to pick my test points between each of these intervals to determine where the solution actually lies. So when you plug the number 1 into this inequality, this is a true statement. When you plug the number 151 into this inequality, this is the false statement. The solution occurs between 150 and 0. 0 is not included, So we will start with 0 and end with 150, parentheses here, bracket there, because of the inequality symbol, 150 is included. All right, our last example we'll go over today is this one here. First thing we'll do is we'll condense by using properties of logarithms, and we get x times x plus 9 is less than 1. Now, unlike before, we can't just simply cancel the logs because there's no log here. Instead, we've got to switch using our exponential switch. And the base of this log is 10, so I'll simply say 10 to the first power is less than x times x plus 9. And I'll move the 10 to the other side by using subtraction. At the same time, I'll distribute the x. So I get x squared plus 9x minus 10, which results in a factorable trinomial. That's what two numbers multiply together to make 10 and add up to 9, x minus x plus 10, and x minus 1, which means two possible solutions here are negative 10 and positive 1. Now, on the number line, we're going to see how I include both solutions and both restrictions in order to find where the actual restriction and where the actual test points will occur. So I'll begin by putting the number 1 and negative 10 on the number line. Then I'll go to the restrictions of 0 and negative 9. In doing this, now I can determine which points are not suitable for testing and which ones are. So starting at 0, the entire problem becomes undefined for any value less than 0. That means that 10 and 9 are both out as possible solutions to this inequality. So instead, what I'm going to focus on are these two regions right here, the one between 0 and 1 and the one greater than 1. In looking at these and plugging those two test points in, I get a true solution here and a false result here, which means the answer to this problem occurs between the argument 0, or the argument restriction of 0, and the value of 1. Because of the inequality, they are not included, and because it's a restriction, it is also not included. Please take a few minutes now to solve questions 5 and 6. Come back tomorrow ready to discuss your solutions or any questions you might have covering these two problems.